Welcome to the Wolfram Language in Section 10 of Fast Introduction for Programmers. This section is about pure functions, sometimes called anonymous functions or lambda expressions. Here's an example of a pure function that adds 1 to its argument. This pure function is applied by using it as the head of an expression, so this input applies that pure function with 50 as an argument. A pure function can be entered with a number sign character to indicate the argument of the function, and an ampersand character at the end to identify the input as a pure function. Pure functions work much like other functions, but are called anonymous functions because they are set up in a way that they don't have names. For example, here is an ordinary definition for a function f that multiplies its argument by 3. And that function is applied like this by using it as the head of an expression. And here is a pure function that does the same operation, which is also applied by using it as the head of an expression. Pure functions can also have more than one argument. Here is a pure function that takes 2 arguments. The arguments are indicated by an integer after the number sign character. This shows that pure function applied to arguments a and b. A is inserted for argument number 1, and b is inserted for argument number 2. The pure function inputs with number sign characters and the ampersand character are actually a special notation for a function called function. For example, here is a pure function that adds 1 to its argument, which is applied by using it as the head of an expression. Just as the pure function ended with the number sign character and the ampersand character is applied by using it as the head of an expression. These are essentially just 2 different notations for equivalent pure functions. Pure functions are often convenient to use in functions that apply functions. For example, this shows a pure function used in the select function to pick out elements bigger than 7. And this shows a pure function used in the nestlist function to create a simple recursive program. And here is one last example showing another recursive program where it is convenient to enter the recursive function, the first argument in nestgraph, as a pure function. You can get more information about pure functions and the broader topic of functional programming by choosing Wolfram Documentation under the Help menu to bring up the Documentation Center page, clicking on the Core Language and Structure button, and then choosing Functional Programming, which brings up this page with links to information about pure functions and all of the functions that were used in the examples in this section. Functional programming using these functions is often the most efficient way of programming in the Wolfram language.